And here's a typical automation system. So we talked about the backbone, but typically you have wireless and you also have the hard connections. And with that, it's just a multitude of systems. You've got sensors, meters, smart meters, power management on when you cycle pieces of equipment. Say, for instance, on an EMS system, you'll identify pieces of equipment like that central plant. And say, for instance, you have a high level limit. Because remember, during peak periods, he was talking about shaving peak period. Once you hit that peak period, that's what you're charged for the entire month. So say, for instance, I hit a peak period and I ran 1,000 kilowatts over my peak. Just one time. It was just for 1 minute. They based my entire bill for the other 30 days. It was their 31st day. The other 30 days on that 1,000 kilowatt peak. So on a smart system, when I'm reaching to that level, it alarms equipment. So it backs down equipment. It raises temperatures or lowers temperatures. It shuts down equipment. So I don't over exceed that peak. On some, you can put load centers and load controllers on some of your, your air conditioning, the wife tries to turn on the, yeah. No, absolutely. You can do it commercial, retail, industrial.
You signed a contract. That's the reason why.
Yeah.
You signed a contract, and they go, I'm going to give you this rate, but you got to guarantee.
That's right. Right. That way they don't have to run the windmills up in California when I exceed my peak, right? Or I spike it, okay? But again, if you consider this, the sensors, the localized systems, the thermostats, valves, controllers, everything ties into one central core. And it completely monitors your equipment. You remember the graphics he was showing us? Remember those? They showed chillers and cooling towers and sump levels and so on. All those are due through sensors. Wiring system, in some cases, wireless as well. Okay. Now we'll talk a little bit about commissioning. Everybody's familiar with commissioning? Okay. All my project folks in class, has anybody gone through commissioning? You haven't gone through commissioning? Has anybody gone through a retro commissioning? Okay. Yeah, you're going through an existing building, right? And you determine what the performance and operations of the piece of equipment. Continuous commissioning is you do it on a regular basis. Part of, I would consider, maintenance plan, continuous commissioning. So commissioning is no more than a planned and integrated systematic process of verifying and documenting that all the building systems perform and they interact according to the design. I shared the story of the duct heaters. Middle of July, typically won't put in the fuses. 15 amp, 20 amp, 30 amp fuses, right? Because it's the middle of July. Who's going to exercise a heater? We'll get back to them. Come December, you turn the heat on and there's no heat. That means you have to send your electrician that you're paying for to put the fuses in, right? So again, part of the commission would have caught that. Middle of July, you go to full cool and full heat, right? Okay. Building commissioning process primarily starts at the planning cycle right up front, right before pre-design. What's the intent of the building, and how do we plan to commission the building, and what's the specifications that the owner, landlord, expects? Then you go from that into the design phase. What would you need to look at on the design phase as far as commissioning? Oh, yes. Okay. Remember the operational, remember the temperatures, the humidity levels, the lighting? All those are going to be included in your design. Okay, specifications for the requirements, right? Now, can you start thinking about maintenance during that time? Absolutely. You can start thinking about maintenance and what's the requirements. If I had a building that was fully operational via an EMS system, some things I would look for is the software, the backup, right? Sensors, redundancy, okay, in regards to that building and its systems and infrastructures. Then you get into construction, the actually installation. So I've gone from design, we're raising the building up out of the ground. Now we're installing the entire systems and the components in the infrastructure. The physical, the hardwiring, right? You're installing your sensors, you're installing the infrastructure, piping, walls, and so on. Again, you're still thinking about commissioning because before I button that wall up, I have to run leak tests. I have to run current load tests, okay? And then finally you get into post-construction, and this is where you go through commissioning and you go into your continuous commissioning. It's funny because after they commission a building, I'm done with it. It doesn't stop. Because once you fire up the piece of equipment and you start using it, that piece of equipment is expected to run 7/24. So continuous commissioning, I go back with my predictive maintenance program and my preventative maintenance program, and I'm constantly looking at what? The reliability and the performance of that piece of equipment. Okay? Because again, what is it? The cost of that building is the labor, the salaries. So the more I can keep the occupants comfortable working in a building, being productive, the more money I'm making for the building overall. Okay? Know those. And here's some examples. Again, they're in your handouts. Retro commissioning, as we were talking about, existing buildings that were never commissioned after construction. A lot of buildings like that. There's homes like that too. They were designed with a lot of errors, design flaws. They were baked right in. You've probably seen some of them in some of your internships. And what do? You just make adjustments as best you can. Continuous commissioning, however, is an ongoing process to resolve operating problems. That's what we continually do. My water's not getting hot enough. I don't have enough water pressure. I keep tripping a breaker. Are those going to be considered continuous commissioning opportunities, right? I don't have enough lighting. I don't have enough cooling, okay? So between the two, which one would be the best? Which one would give you that robust maintenance program? Continuous commissioning, right? Absolutely. Okay. Now, some energy audits. Typically, these are your four main groups. One is lighting, huge. You're just talking about LED lighting. You'll be surprised how much power you use in lighting. Okay. The next one would be the building envelope. What's to do with the building envelope? Pressurization. How tight it is, right? Okay. Heat transfer between the walls, the roofs, right? R values, is it single, dual pane windows? Are they insulated, right? Vacuum jacketed or not? Next one is HVAC systems, right? Heating, ventilation, and air conditioning. The other facility equipment is items such as copiers, right? Coffee machines, believe it or not. Components such as cafeteria, dishwashers, maybe the toasters, right? Heating elements and ductwork and so on. Those would be considered other types of facilities equipment. Okay, computers, hard drives would be part of that. So now we get into facilities management systems and provides building systems reliability and operations. So what we want to do is determine the optimal business or building equipment and systems performance levels. I want to run this piece of equipment at its optimum performance level, at its optimal cost for as long as I possibly can. Okay, monitors and operates rooms and process water temperatures, consumption. Okay, all these are components, and the most item is having trained personnel being able to run it. Okay, and typical energy management devices, workstations. You saw that in the computer terminals, data gathering points, otherwise known as MBCs. These are modular building controllers. These are remote units, and they're throughout the building. Do you remember the panel I had to add for my fire protection system? I had the same issue with my building energy management systems as well. Sometimes I will overtask that MBC. I have to add another one or expand it. Maybe I want to monitor additional equipment or additional rooms. So I need to put more sensor points, which means I have to upgrade the infrastructure. Okay. And of course, you have your field devices, which are primarily relays, sensors, variable output devices. Now, every one of these is going to require maintenance, especially the field devices. So part of your PM, if you're out working on an air handler, you will exercise the valves and probably look at your dampers and your actuators. You're there, you might as well take a look at them and exercise them as you're there, and then record the operation. Do they meet the specifications and criteria? Okay. And some maintenance practices, just regular diagnostics, typical maintenance or software upgrades on a regular basis, specialized training, service logs. There's those books. Remember that? Okay. Energy backup components such as UPSs. Maybe you're going to have fuses, maybe some extra MBCs, maybe some extra sensors. Water sensors are huge in a data center, right? Temperatures, humidity sensors. Okay. And then emergency operations and plans manuals. What happens if this system crashes? What happens to the building? Send everybody home? What do you think? Oh, you don't want to send everybody home, so you got a backup plan. So typically in an EMS system, the systems you're going to predetermine, do they fail to full heat or full cool? So say we're in the summertime, okay? Do I want my systems to fail to full heat or to full cool? I probably want to go to full cool. I'll pay the extra for energy, but I don't want to send anybody home because then I'm talking about labor. Say, for instance, I'm back east and it's in the middle of January. Do I want it to fail to full heat or to full cool? It's probably going to be heat, to full heat, okay, depending on what the application is. But the nice part about your emergency preparedness, you can pre-program. So you can install your actuators and your valves and your sensors. Is it too full or too? So they go either way, okay? And what you're doing is you're buying time. You're buying time to get the systems back up, determine and troubleshoot what the fault is, okay? Reviewing systems and alarm trends. You know, every morning we get the same cold call from the same room every morning. So that should be telling me something, right? I mean, after 30 calls, you know, between 7 and 7:30, it's the same call, I'm too cold. And you look at your EMS and it says, you know what, it is. It's 62 degrees in that room. After 30 alarms, wouldn't that tell you something? You think maybe we should go look at it? What do you think, Suze? Probably, right? Yeah.
But you get a lot of guys that'll just go in there and just ignore the alarm points and then just forget about it. They'll hit it again tomorrow morning and it'll happen again.
Oh, it's just a quirk. It's a glitch. It's a system glitch. It'll clear up next month, right? Right? Now, my facility, remember those charts that I showed you that had the hot and cold spots? Remember that? The cool colors and everything in there? My facility, the Hayden, the North facility, North Campus, was built in 54 and it had additions on up into about 91. Okay, when they built the first manufacturing bay, it was about 1964. Okay, it was a large open area, so you can go up and see the T-packs. You can see from wall to wall, and it was just a large duct. And on top of that, we had large air handlers, large penthouses. So this is one of the very first air-conditioned facilities in the valley, in Phoenix. Chill water, we had a central plant, right? So the valves, I call those the man valves. These valves stood about that tall. Large 6 to 8 inch, right, air-actuated chill water valves, hot water valves. And the reason I call those the man valves, because they were big valves, right? Manly valves. When we went through and we started to conduct our assessment about 12, 15 years ago, we found out that even though we had a BCAS system, EMS, and we were monitoring the level of those valves because they were so large and they were air actuated, when we would call it to actually maybe heat the room up to say 72 degrees, the valve was so large that it overshoot that 72 and go up to 77 before it reacted, right? And then remember, we changed the building. We cut it up. We put hallways in. We put offices in. So that large valve wasn't cooling a large manufacturing space anymore. A lot of little spaces. Now we get a call. I'm too hot. What are you guys doing? Oh, you know what? We've got to drop the temperature. Well, drop it down to 70 degrees. Well, we drop it down to 70. It overshoot to 70 and drop it down to 64 degrees. What do you think our customers were thinking of facilities? What are these? Yeah, what are you guys doing, right? We came back and they took out my manly valves. I couldn't believe it. Do you know what size valves they put in? They put little electronic valves about that tall. They went from 6 inch to 4, 4.5. They went from 8 inch down to 5, 5.5 valves. But what happened with electronic, once I set it at 71 degrees, guess what? It hit 71, give or take 0.01 degrees. I was spot right on. So what that did to my central plant, it kept chillers from exercising and shutting off, starting an exercise. So if I start a chiller during peak period, what does that do to my spike? It spikes it, and what does it do to my energy? So it's all relative, okay? Good, okay? All right, let me see here. What else I got here? Again, just some of the contingencies, loss of communications, we talked about that. Electronic logs, but also keep paper logs, okay? maintenance programs, backup systems. I love electronics, I love databases, but they can fail. Okay? Continuity of services, redundancies, access to remote workstations and devices. Since you can VPN or remote in, we have individuals that take laptops home and they have a computer at home where they could log in from Sholo, or if they live in Payson, they can access my facility right through a secured, encrypted line, and they can actually manage equipment, start top, air handlers, turn on lights and so on, and they can do it from a remote basis. This is great because if I have somebody on call and they're not in the facility, I can go to one of our remote operators, have them operate that as well. Lighting, cooling, communications, backup servers, okay, as well.